Hi everyone, and this is the lecture for the course module number 8. All right, and you have the documentation, so let's take a look at the documentations. All right, and then there are quite a few material you can study, but we're going to just briefly talk about what's the content so you have an idea what is this about. Keypad. All right, the keypad, basically there are three different types, and actually two types, is the matrix keypad and then with the E-line type of keypad. And we used to use 3x4 keypad. It has the 12 key, that's the orientation and also the pin connections. All right, and then that was used for the past for trainer module 1-2. But with the module 2, Rev 2, then you will have the 4x4 keypad, and then the pin is at the bottoms, and then the labels of those pins are N, 0, N1, N2, N3, N4, N5, N6 in this layout format. There's a particular type of a keypad which we has an E-line, so if you can use this particular keypad, but the E-line could be either hooked up to ground or 5 volts. That has to be opposed to whatever the pin being pulled high or pulled low. Then if any key being pressed with the E-line type of keypad, it will generate the unique combination of those 1 and 0 in a byte format. All right, but unfortunately we don't have this E-line of a keypad, and then also it costs more to purchase. Majority of those key are the matrix keypad. If you look at the matrix keypad, let's concentrate with the 4x4. Then once you plug in the keypad to the trainer board, all those pins being pulled up with 5 volts through the 10K resistors. So if you want to sense the action, read the key action from the user as a system, then if you just make all those interface as an input you read in, you're going to read all FF, that means all ones. Then if there's any action, for example, you have an action on key 1, then N3 and N7 will be shorted, but both of them will be pulled up with the 10K pulled up. So they will be in parallels. You still have 5Ks pulled up. So when you go ahead to read it, you're still going to read FF, that means all one. So for this type of matrix keypad, if you just go ahead to read the pin, it is not going to work. So we have to do a little bit creative things. We call it scanning. So basically you need to artificially create the zeros. For example, in this case, we have N0, N1, N2, N3. We call them row because they are horizontal. N4, N5, N6, they are columns because they are vertical. So we are making N4, 5, 6, 7 as an output. All right, then you make the row N0, N1, N2, N3 as the input. Say we are putting N7 to be 0. Then you read it. The scanning is you put one column on 0 at a time, then you rotate those 0 through all the columns. So for example, if I have N0 and N7, then one on N6, one on N5, and 4, then you immediately read. Then you are scanning star, 7, 4, and 1 because you are detecting N0, N1, N2, N3. Then you rotate, you move on to the N6 to be 0, the rest to be 1. You are scanning key 0, A, 5, 2. Then you move on to make M5 to be 0, the rest are 1s. You're scanning pound 9, 6, and 3. Again, you move M4 to be 0, the other will be 1. You're scanning the D, C, B, and A. All right, that's what we call scanning. So we need, there are many themes and talk about this in the following description. All right, we are scanning the column and those. Then let's go follow the flow chart. All right. Output on the column reads on the row. In this case, output on the column reads on the rows. Let's go to the flow chart. You can go ahead and read it. Flow chart, basically, you set up 4x4, you clear the flag. The flag, this is a software flag to indicate how you're going to get out of the loop. All right, we're going to come back to this. Then you're going to set it up 4 input, 4 output. 4 output will be on the column side, 4 input will be on the row side. So we're going to set the index. The index is for the table lookup purpose. We haven't touched that yet, but we will come back. First, scan the first key. First, scan the first column. First column, make sure you got a 0 on the first, which is N7. Then N6, N4, N5, and N4. Okay, rotate. So you do that one at a time. Scan column 1, column 2, column 3, column 4. Once you put that, you know you need to read the key. So we call it check keys. If you look at the check key, basically, you know there are 4 rows coming in, so you set the counter as 4. You basically copy that counter into a byte of the data memory, then you rotate. All right. If you look back on page 3, those are the rows you rotate. Since N0 will be the pin most likely to be the LSB, so you rotate to the right. If it's opposite, then you rotate to the left. All right. It depends on your interface. So let's come back to the check keys. We know we're going to have a 4, so we're going to rotate left or right. In this case, we rotate right. That the key on the rows will be kicked into the C flag. If the C flag is 0, you know that keep in touch. If it's not, you move on. You increase the index, which is a counter type. Then you have 4 keys. So we set the counter to do it 4 times continuously. If there's nothing happen, you're going to return. If there's something happen, that means there's a key being pressed. All right. Then you need to save the index. All right. That's used for the table lookup or to check the key face value. Then the next thing is because of mechanical contact point, the key will be bounced. So we need to come up with the debounce strategy. The debounce is very simple. Okay, let's come back to debounce routine. Debounce. Debounce is very simple. Basically, it's blindfolded. The reason we get a debounce is because we detect the 0. So we go ahead to read all those columns again and make sure non-zero exists. For example, you rotate, you copy the row. Okay, you copy the rows into the memory, you rotate to the left. If you see a 0, that means you got a bouncing coming out there. If that's the case, keep on reading it, keep on reading it. Then you rotate that. If it's not, then you move on to rotate the second one to detect the second row. Then if you see a 0, continue, stay there forever. Detect the third row. If you see a 0, continue, stay there. Detect the fourth row, continue, see 0, stay there. If it's not, then you let it go, you go back. You're done with the debounce. So the debounce is not discriminate which key. Basically, you make sure all the 4 rows key, which is on the input side, does not get you any 0. If that happens, that means the key is not bouncing anymore. All right. That we did on the flow chart. We did scanning. All right, basically scanning column. Scan the column 1, column 2, column 3, column 4. Then you do a check key. If you see the key, then you're going to set a software flag. Okay, look at that. You're going to set a software flag here. After you've done debounce, you set a software flag here, you return. It will bring you back to the flow chart here. Then you clear that software flag. All right. Because that will bring you back here. I'm sorry, that will bring you back here, here, or here, or here. If the software flag is set, that means you don't have to loop and keep on scanning. You can get out. That's the purpose of that software flag. Otherwise, you're going to get indefinite loop in this flowcharts. So the flag is set. You get out. You clear the flag. Then we're going to do the decode. All right. Remember, we have a counter we put it in, index, or we call it index. Index to keep on incrementing. Since you got 16 keys, the index start with 0, which is here. Then you increment each time you move on to different key, move on to different keys. Since we have 16 keys, so the index will start with the 0 up to F, which is 15. All right. That is the information you use for the decode. All right, so you copy that information into the W, then you call the key table. Once you're coming out of the key table, you will retrieve a key face value. Now, let's take a look at how we're going to decode. For example, we have something here in the handout. Let's move on to page 14. All right, here is the key face value of the keypad. All right. Depends on the sequence. In this sequence, we send N7, N6, M5, M4 as an output. We read it immediately, N0, N1, N2, N3. So the first thing you do that, you are checking *741. start 741. Then you move on to the N6, you read it again, it's 0852 pound 963 DCBA. Those are the sequence you have to put it in. Based on the sequence, because each time the index will be bounded with the key sequence. In this case, it will be 0, 1, 2, 3, continue until 10, 15, 14, 13, and 12. All right, so with DCBA continue. So they are total 16, but that index start with the 0. So you save that, you move that index to W, you call this table. The table basically is the same as the LSD module, that it will return the ASCII code of the equivalent key phase value in this case. Now, certainly if you do a little bit differently in the wiring, then your key phase table will be different in this case. Then if you have some other keypad in the future, you have some screwed it up, we did on purpose with a different case value, then all you need to do, all right, you don't have to change anything. All you need to do, all you have to do is to change the key phase value table. In this case, it's that table. In this case, that's the table. All right, you will have a lab associated with this, and we will ask you to run this, and you can change the sequence and change the wiring. Then you can detect any keys phase value. All right, and this will conclude this lecture for the course module number 8. Thanks for attending.